Okay, now we're entering the section of this course where we're going to look in more detail at forward contracts, futures contracts, and swaps. We're going to start off in this chapter with some of the basics of pricing forward contracts and, of course, by extension, futures contracts, since they are very much like forwards. We're going to begin by looking at forwards and futures where the underlying asset is either a stock or a stock index. And we already have some idea about how these contracts might be used. We talked about that in the first part of the course. Now the question really is, how are the contracts going to be priced? How is the forward price or futures price going to be determined? And then after that, we'll talk a little bit even about how you might hedge a position with forward contracts involved. Now, hopefully you remember that the only difference between buying a forward contract and buying the underlying asset outright is timing. It's the timing of when you pay for the goods, whatever it might be, in this case a share of stock or a stock index, and when you actually receive it. So let's talk about that. Let's explore that issue. We're going to look now at 4 different ways that you might potentially acquire a stock. And in each case, you have a choice of either paying now or paying for it later. And then also you have the choice of receiving it now and receiving the stock later. Let's look at each one of the 4 possible choices. If you did just an outright purchase of the stock, then you would just pay for it now. You would pay for it today, and you would receive it right away. That's the usual method. That's what we would call a spot market transaction. And trades like that occur all the time. So if you did it this way, then what would you end up paying? Well, that's easy. You would just pay whatever the stock price is at time zero. And time zero, of course, is today. Now, let's look at a slightly different method. Let's say we wanted to do a fully leveraged purchase of the stock. In other words, we borrow money to purchase a stock. Well, because we borrow the money, there really is no net payment today. There's no net cash outflow. The cash outflow, that is the payment, occurs when the loan comes due. And we're going to assume for this example that the loan comes due at time t in the future. Well, in this case, you received the stock at time 0 today, but the payment didn't happen until later. So what do you think the payment would have to be? Well, it's going to be S0 times e to the RT, assuming that we have continuous compounding and assuming that you are able to borrow at the risk-free rate. Now, why is that true? Well, the answer is because you had to borrow S0. All right, that was the amount you had to borrow to make the purchase. And then, since you're paying later, there's going to be interest that accrues on that loan at the rate of R, which is the risk-free rate, for a length of time T. And so the amount that you have to repay on that loan at the future date is S0 times e to the RT. In both of those transactions that we just looked at, you received the security today, but that's really not the way it works with a futures contract or a forward contract, which is what we're looking at right now. In the next 2 types of transactions, you're not going to receive the security until a future date, that is time t, some point on down in the future. Now the question is, when are you going to pay for it? Are you going to prepay for that asset? That is, are you going to pay for the stock in advance? Or are you going to pay for it later? Well, with a prepaid forward contract, you would pay at time 0, that is today. You'd pay for it now, and then you'd receive the stock at a date in the future. And we really don't know yet what price you would have to pay, what payment would have to be made in order to acquire the stock this way. But we'll come back to that question in just a minute. With a forward contract, see, there's no difference in when you would receive the security. You would receive it at a specified future date, basically the same point in time, but there is a difference in when you pay for it. And in fact, that's the only difference. So the payment would have to be for a prepaid forward contract. I can guarantee you that for the regular forward contract, the price that you'd have to pay is just going to be that amount plus interest. Because again, that's the only difference between a prepaid forward and a regular forward contract, is when the timing of the payment happens. And again, I'm assuming that you can borrow at the risk-free rate, which is continuously compounded over that time period. So it seems now that we just need to be able to value a prepaid forward contract, and then we would pretty much know what the forward price should be. And in fact, that's true, and that's what we're going to look at right now. How do we price a prepaid forward contract? Again, this is a type of contract where you pay for the stock now and you receive it at a specified future time T. And we want to figure this out because if we can, then we can simply price a regular forward contract by finding the future value. That is, just compounding it forward continuously at the risk-free interest rate. Well, there are three alternative methods that we might use to price a prepaid forward, and they all lead us to the same answer, but it's sometimes useful to look at different methods for pricing because one of them is probably going to make more sense to you. It's going to be a little more intuitive and convincing than the other methods might. So let's look at pricing by analogy, pricing by discounted present value, and then pricing via an arbitrage argument. Okay, for now we're going to assume that the stock does not pay any dividends. Now, don't worry, if the stock does pay dividends, there's definitely a way that we can adjust for it, but we'll start with the simple case again where the stock pays no dividends, and we will see how to price a prepaid forward contract, again, where there's no dividends paid between today and the expiration of the contract. First of all, let's just think about it. Let's price this thing by analogy. If the stock pays no dividends between time 0 and time t, then it doesn't really matter to the investor where along that timeline they receive it. I could receive the stock today, or I could receive the stock in the future at time t, and I haven't really missed anything, and I'm not really counting anything like voting rights in the picture here. If a stockholder is well diversified, then they probably aren't going to own enough of the stock to where control in the company and voting is a big consideration. So that aside, it really doesn't matter whether I receive the stock today or in the future at time t. So the timing of delivery is irrelevant, and that being the case, the value of the prepaid forward contract should be equal to the value of the stock itself. Well, that seems very simple, maybe almost too simple. Maybe you need a little bit more convincing that in fact it's true, that a prepaid forward has the same value as the stock itself whenever there's no dividends paid by the stock over the time of the contract. Well, okay, let's price this via a present value type argument, and we're going to assume that for this stock that our appropriate discount rate is alpha. We're not going to discount at the risk-free rate because the stock is a risky instrument. So it's going to have a risk-adjusted discount, which you can determine using something like the CAPM, the capital asset pricing model that you had in your first finance course. Okay, so let's go ahead and figure this out. When we price things by present value, what do? We simply take the present value of the future cash flow that the asset is expected to produce. So what is the expected future stock price? Well, it would just be today's stock price, or S0, compounded forward at the required rate of return. So we would multiply S0 times e to the alpha t. But don't forget, we have to take the present value of that expression. as shown in this equation. We have to take the expected future stock price and then discount that at alpha, the required rate of return for the stock. So if I plug this expected stock price, S0 times e to the alpha t, into this part of the expression, then what's the result? I'm going to have S0 times e to the alpha t times e to the minus alpha t, and what does that leave me with? Just S0. So again, the result is that the prepaid forward contract has the same value as the underlying stock itself. Alright, now just in case you're still not convinced, let me use the most powerful argument of all, and that is a no arbitrage pricing argument. Arbitrage is essentially free money. Arbitrage is a situation where a person can generate guaranteed risk-free positive cash flow with no investment of their own wealth. And that's usually accomplished through some sort of setup where you buy one asset and you sell another asset that is related to it. Now, in the real world, we know that free money is very hard to come by. So it's going to be very hard to come up with an arbitrage opportunity that will actually work and actually earn you money with no risk and no investment of your own capital. Nevertheless, these arguments are going to be incredibly useful in helping us understand why certain derivative securities must be priced the way they are. Okay, we've already said that a prepaid forward contract has to be priced exactly the same as the underlying stock, assuming there's no dividends between time 0 and time t. Well, suppose that wasn't true. Let's suppose that the prepaid forward contract was more valuable than the stock itself. So the prepaid forward price is higher than the stock price. Well, then here is what an arbitrager would do. Now, an arbitrager is always going to want to sell whatever is overpriced and buy whatever is underpriced. And in this case, you have a prepaid forward contract that is overpriced. Simultaneously, you have a stock that is relatively underpriced relative to the prepaid forward. Obviously, what we'd want to do is buy the underpriced stock and sell the overpriced prepaid forward contract. Now, exactly what cash flows would result from that transaction? Well, first of all, let's look at what would happen as a result of us buying the underpriced stock. We would have a negative cash flow from that today because we'd have to pay for the stock. We'd have to pay the stock price right now at time 0. And then, of course, at time t expiration, we would have the stock, and that would be worth S sub t, the stock price at time t. Alright, now what about the prepaid forward contract? Well, if we sell one of those, then remember, payment is made today, so we will receive the price of the prepaid forward contract right now. And then in the future, we will have to deliver the stock at time t, and that will cost us S sub t. So what are the net cash flows then on each date? That is time 0 today and time t, the expiration of the contract. At time 0 today, we obviously have the prepaid forward price which we get minus the stock price which we pay. So that's the net cash flow. And of course, that's a positive number. Remember, we're assuming in this example here that the prepaid forward price is higher than the stock price. So that's going to be a positive cash flow today. And let's see what would happen as a result of that position. Well, the answer is it would be no harm, no foul in the future. We would have a net cash flow of 0 on the expiration date. Essentially, what would happen is that stock that we purchased, that we now own, we would simply turn it over to the owner of the prepaid forward contract. But we would have already reaped a positive cash flow at time 0 with no further consequences as a result of the transaction. That would be free money. We would make the difference between the prepaid forward price and the stock price times however many times we did this, however many contracts that we entered into, again with no further consequences. So if this sounds like free money, it is. That's what arbitrage would be. Now, of course, I hope you're a little bit skeptical about any kind of arrangement like this that would earn you free money, because, as I said before, that's extremely hard to come by in the real world. And if it ever did occur, I think we could pretty safely say that the opportunity wouldn't last very long. What would happen if this opportunity really came up in practice? Well, you would have so many people wanting to buy the stock that S0 would rise, and you would have so many people wanting to sell the prepaid forward contract that its price would fall. And so the difference between the two would be eliminated. So in essence, what we've shown is that the price has to equal the stock price, because if it was more, then an arbitrage opportunity would exist. There would be free money available. And if it was less, there would be a similar arbitrage opportunity which you could just as easily demonstrate, except that you would short sell the stock and you would buy the prepaid forward contract. But the conclusion is the same. Since these arbitrage opportunities cannot exist for very long, if at all, then in equilibrium, the prepaid forward is going to have the same value as the stock itself. Now let's ask another question. What if the stock pays dividends? So far, we've been assuming that there are no dividends paid between today and the expiration of the contract, but what if that's not true? What if, in fact, the stock does pay dividends between right now and when the contract will expire? Is the pricing relationship still valid? Is it still true that the prepaid forward price equals the stock price? And the answer is no, because now the timing of delivery does matter. By waiting until later to actually receive the stock, the person who buys the prepaid forward contract is going to miss out on whatever dividends are paid between time 0 and expiration. So what does that mean for the value of the prepaid forward? It simply means that its value is going to be the stock price minus the present value of any dividends paid between today and contract expiration. And so that means the prepaid forward is going to have a value that is less than the current stock price. And the more dividends that are paid, the bigger the difference will be. If dividends are paid at discrete times, as is typically the case with an individual stock, then all you need to do is figure the present value of each one of those dividends and subtract the total present value off of the current stock price. On the other hand, if dividends are paid more continuously, as might be the case with something like a stock index, or at least it would be a good approximation, then you can use a more continuous valuation formula. You can take the current stock price S0 and you can simply multiply it by this factor e to the minus delta t, where delta is the annualized dividend yield expressed as a decimal, and t is the amount of time until that contract expires. Let's look at some examples of how we might handle this situation. Let's say that XYZ stock has a value of $100 today, and it has a quarterly dividend of $1.25 per share. Our risk-free interest rate in this case is going to be 10% compounded continuously, and we want to know how much a 1-year prepaid forward would cost on XYZ stock. Well, in the absence of those dividends, the prepaid forward would cost $100, the same as the stock. But since there are going to be 4 quarterly dividends of $1.25 each that are paid, a person would miss out on those dividends by owning a prepaid forward contract instead of owning the stock. So in this case, the prepaid forward can't be as valuable as the stock itself. It has to be the stock value minus the present value of those 4 dividends. So how do we know how much the present value of those dividends would be? Well, this is how I would go about it. Let me get a calculator up. What I would do is just figure the value as follows. I would start with the $100, and then I would subtract off the present value of each dividend one by one. The first dividend, $1.25, times the discounting factor, here we go, e to the negative 0.1, since 0.1 or 10% is our continuously compounded interest rate. But remember, the first dividend happens 1/4 from today, a quarter of a year, so I'm going to divide that by 4. Then I need to subtract off the present value of the next dividend, $1.25 times e to the minus 0.1. Okay, and in this case, it's going to be 2 quarters away, or half of a year. So you could say something like minus 0.1 divided by 2 for this exponent, or if you wanted to express it a different way, you could say times 2, since it was the second quarter, divided by 4, because there's 4 in a year. Now we've got to subtract off the present value of the third dividend. Okay, $1.25 times e to the minus 0.1 times 3 divided by 4, okay, because it's 3 quarters of a year away. And then finally, subtract off the present value of the last dividend, minus $1.25 times e to the power of minus 0.1. And of course, that's a whole year away, so it's not a fractional portion of the year. We'll just go with that interest rate. Close this expression out. And of course, we find that the answer is $95.30, which is exactly what shows up on the lecture slide as the answer. So we've worked the problem correctly. Okay, now let's take a look at an example where we have a stock index, and it has a value of $125. And since a stock index consists of many different stocks that pay dividends at different times, it kind of starts to approximate more of a continuous dividend stream. So let's say that the dividend yield on average for all these stocks is 3%, and because it's a stock index, it starts to look more like a continuous stream of dividends that amounts to 3% per year. Well, in this case, we don't have to worry so much about finding the present value of each one of those dividends one by one. That becomes a bit of a hassle. We can use more of a continuous valuation formula. All we have to do is take the current value of the index, $125, and we multiply by e to the power of minus 0.03, because 3% is the continuous dividend yield. And then, of course, we have to multiply that according to the formula by the number of years in the term of the prepaid forward contract, which is, of course, in this case just 1, but I just want you to see that it's there. You do have to multiply minus delta times t in the exponent. All right, and in this case, t is just 1 because the prepaid forward contract has 1 year to expiration. And we hit enter, and of course we get $121.31 would be the prepaid forward contract value for this stock index. Okay, so now we've figured out how to price a prepaid forward contract on a stock, but that's not mainly what we're interested in. Mostly, we're going to be dealing with the price of forward contracts, not prepaid forward contracts. Forwards are what we encounter more often in actual practice, and so that's what we want to know about. Well, remember from our earlier discussion that there were different ways that we could possibly buy a stock. And the only difference between a forward and a prepaid forward is that the timing of the payment is delayed. With a prepaid forward contract, we make our payment today. With a forward contract, we make the payment at expiration, that is in the future at time t. Everything else is the same. So the only difference is that the forward price is going to have to be the future value of the prepaid forward price. It's going to have to be the prepaid forward times e to the RT, where R is the continuously compounded risk-free interest rate and T is the amount of time until expiration. So, how do we price a forward contract, which is what we were really trying to get at? Again, we're just finding the future value of the prepaid forward contract's price. So if there are no dividends paid by the stock between now and contract expiration, then the prepaid forward would just have a value of S0, and so we would find its future value multiplying by e to the RT, and so the forward price would just be S0 times e to the RT. And if it weren't, there would be an arbitrage opportunity. If the stock paid dividends discretely, that is, at certain points in time, then we would take the pricing formula for a prepaid forward, multiply it by the same factor, e to the RT, and this is what we would end up with. And then if we had continuous dividends, which frequently for a lot of our mathematical modeling in this course, that's what we're going to assume, then we would just take the prepaid forward pricing formula, remember S0 times e to the minus delta t, and we would multiply it by e to the RT, and the result would be S0 times e to the R minus delta t. Now remember that's a very important formula that we're going to come back to quite a bit in this course. Sometimes when we talk about forward contracts and their values, obviously there's usually a difference between the forward price and the current, that is, the spot market price of the stock. The percentage difference between the forward price and the current spot market price for the stock is called the forward premium. If the forward price is more than the current stock price, then we say that there's a forward premium. If the forward price were less than the stock price, then we would say that there was a forward discount. Now we can express the forward premium on an annualized basis using this formula. We just take 1 over t times the log of the ratio of the forward price to the spot price. So with a scientific calculator, that's a pretty straightforward calculation to do. And if you get a positive answer, then there's a forward premium. If you get a negative number, then that means that there's a forward discount, meaning that the forward price is actually less than the spot price. How could you know under what conditions that was going to happen? In other words, how would you know when there was going to be a forward premium versus a forward discount? Well, actually, if you look at the formula on the previous page, it's pretty easy. If the risk-free interest rate is more than the continuously compounded dividend yield, then this factor, e to the r minus delta times t, will be more than 1, and it'll cause the forward price to be more than the current stock price. On the other hand, if it's the other way around, and if the continuously compounded annualized dividend yield is more than the risk-free interest rate, then you're going to have a forward discount because e to the r minus delta times t is going to be less than 1. If you're not convinced, of course you can work through a few examples and see that this is in fact true.